For my final build of the knife sharpener and teacher on how to sharpen knives, I present my masterpiece. Now, before I talk about it specifically, I'd like to sort of talk about something that really struck me about the way Mark runs his workshop. From the first second I saw his workshop, I thought, boy, that's so clean, it's so organized. In fact, at one point he said something like, if things are a mess, I can't think. Well, if you look at my workshop, you would imagine how I can ever think. I mean, what a mess, huh? Yeah, and it goes on and on like this. Well, what I realized is that, I hope I realized that there are different ways that you can be creative. And I'm a slob, and Mark is a neatnik, and obviously his method works fantastically. But I think my method works okay, and it may not be as sloppy as it appears, because this is my classroom. And at the start of a year, I have a lot of boxes you can see over there. When kids walk in, I tell them, please don't mess with stuff, just leave it where it is. For example, here we have some ant farms, and here we have a little artwork, but it's not just artwork, it's also antwork. Yeah, because the ants are making great things in their ant farms, and the kids are taking kits home to build their own ant farms and then have fun. Well, at the start of the year, I'll tell the kids, don't mess with my stuff. But to prove that things actually might be better organized than they think, and that what looks like just, random trash sitting out on the desk may actually be, well, it could be part of my COVID sculpture here. This is the mobile sculpture encouraging people to wear masks, and there's COVID down there. And yes, those are real chicken feet on COVID. To tell students not to mess with my stuff, I say, you, just 3 random kids, go over to my shelves and pick out anything from any box, bring it up front to me. Now, I'm going to be up front here, blindfolded, facing the blackboard, and just put it in my hands and behind my back, and I will try to tell you what it is and where you got it. And I can usually bat about 800 on that. About 80% of the time, I can tell them what it is and where it came from. Even though it looks like chaos, it's not chaos inside my mind, because I use all this stuff, and so I get constant review sessions. Well, enough of that. So let's talk about the actual sculpture. It is a sculpture, maybe. Kinetic sculpture, my knife sharpener. So one of the things that somebody said was, get the wires. I appreciate their comment. You should get the wires looking more neat. And you should, maybe, Mark said, presentation is definitely what you want to do near the end. Well, I thought about it. And I thought about how I could make this thing look cool. I thought about unscrewing the whole thing and painting it and whatnot. I tried a couple of things. I thought, well, I will put hula girl, those Hawaiian girl bobblehead things that sit in the back of cars. I thought I'd make a hula thing, because this thing goes back and forth like this. And so, the hula skirt would go back and forth. Well, that didn't work too well. I have a circle here, so I thought, well, I could put a Benham's disc on there. So I made a little Benham's disc, but it didn't go fast enough. Benham's disc, that's the thing that it looks like this when it's still, but when it spins, it looks like you see colors there. I see some orange and purple and stuff. It's just an optical illusion. But the rotational rate of that thing, this is going faster than my thing was. So it didn't rotate quite fast enough. And so, I ended up making a little, those wave boxes that have blue liquid and then mineral oil on top. I made one of those guys. I thought, man, those look so cool. But the one on the YouTube from Wayne Schmidt, which is a great site, said, make it 2 feet long. Well, this is so short. If you go slow speed, it's really boring. And even if you go fast speed, it's kind of boring. But it doesn't make those cool waves that are breaking stuff. That's without the mineral oil. When you put the mineral oil in, it does even less than that. So this is, that's all I got. It's not that great. Maybe it's better than nothing. Maybe it just gets in the way. anyways, so let me just quickly review how this thing works, and then I guess we'll be done, or something pretty quick after that. So basically, it's a very simple thing. I just have I have 3 different honing blocks here. They come from Harbor Freight, diamond hone blocks, and I suggest you get a set for $10 because they're really great for sharpening knives. That's coarse, medium, and fine. And all you do is, I have a triangle here, equilateral triangle, so all 3 of them are set up like that. There's a 60-degree angle inside this hole here, and you notice I put this cool diffraction tape all over it. That's my concession to trying to make it look good, even though it's kind of dumb. Anyways, then you turn this thing on high speed, and all you do is take your knife and go like this on both sides, and then switch over to the next grit, which is going to be medium grit, and then do the same thing on fine grit, and then you have your knife sharp. So to check and see if your knife is sharp, because it's pretty tricky. What you really are best off getting is a several $100 dissecting microscope like this. It has a light on it, and I'm a science teacher, so of course I have access to things like this. It's binocular, and that way you can actually see the blade and see how your sharpening is doing. But you can never tell by just looking if a knife is sharp. The only way to tell is by the tomato test, the t-test. So, as I said before, but maybe you didn't see that one, I have a hard drive magnet there that holds the knife. And then you put, this is a piece of aluminum here on the table, and you put a tomato down inside there like so. And then there's a little timer you can put on, so it counts the number of strokes that it does. Every time it does a stroke, it makes a beep. And you also have a counter here so you can see. So every time it goes down and back once, that's 7 plus 7 is 14. And then this keeps the count of that. And then the final number, like if it's 14 and if it gets to 2, that would be 16 centimeters it took of sawing to cut through the tomato. That way you have a way to quantify how good your cut is. So what you have to do is hook up one of these 2 wires to the plate, the metal plate that's underneath the knife, and the other one goes onto the knife itself. So when the knife touches the plate, it completes a circuit that turns on the coil of a relay that turns off the cutter. So you can tell exactly how many strokes it takes to, cut through the tomato. So let's see what we got here. We got our counter set at 0, and we're about ready to go. So let's see what we got here for total strokes. So, turns out that was a pretty good cut, huh? So it was 1 centimeter, and then it did already a 1 here, so that's 7 plus 7 is 14. So that's 15 centimeters of sawing it took to cut through that tomato. That is a sharp knife. So the whole point of this thing over here is kind of dumb, but I had to come up with something that looked like eye candy. So this is just a simple spiral, and if you turn this thing on fast and have it run, and just look at it for a while, you don't need that sound, just stare at the middle, and then stop and look at anything, and you see the way it looks like we're going away from a big, tall cylinder, we're like out in space, moving away. Well, if you stop this thing and look anywhere, the ground looks like it's expanding. So a quick look at the ground someplace. See the way it looks like it's expanding? I don't know. That's kind of dumb, but anyways, that's the only way I could think to make this thing look cool, besides my cool diffraction tape on the side of this thing. So that's my project. I learned a lot. I had a lot of fun. I learned that I really like electrical stuff, even though I'm supposed to be doing mechanical stuff for this first build. And I guess that's all I have to say. So now for the epilogue of this already too long tale. You see, it was the night before it was due at midnight, and I was down at school. I made the whole thing, the video you've seen, and then I put the segments on Dropbox, which of course sends them right to my house where I have my video editing software, Shotcut, which if you don't know about Shotcut, check it out. It's a great video program for free. Well, I got home and started to work at 9 o'clock, knowing I had 3 hours till the 11:59 deadline, and then I realized it didn't come to my house. I had somehow not sent it correctly. So I wasn't going to get my bike at 9 o'clock at night and ride all the way back to school, and the school was locked, and I was pretty depressed. But it turned out to be good, because I came down to school today, and on the way, I thought, why not stop by some of my neighbors? And so I was able to get them to loan me their knives and say, hey, I'm going to sharpen your knives. I said, okay. They probably think I'm a nice guy. Actually, I'm just using them, because what I realized was, and something that's true not just on knife sharpeners, if you have a thing and you're trying to make sure your invention works, try it over and over again. Don't just try it once and say, oh, it works. So I thought if I can sharpen 4 knives, then all that time will be spent, learning whether or not this is in fact a good method. And I discovered some really important things. So one thing I discovered was that it's really hard to hold the angle of the blade exactly where it's supposed to go, In fact, it's impossible. So I invented a little device to do that, and I'd like to show that to you. It's a very simple device. It's just a little magnet and a 19-degree wedge of wood, and then one of those little levels that you've seen, carpenter levels. And it turns out I did some research that most knives are between 20 degrees like that and 17 degrees in terms of their sharpness angle. American knives are 20, Japanese go for 17 more often. Well, what's the difference? Well, the difference is 17 is sharper. I mean, it's a thinner blade, so it cuts better, but also it's a sharper tip, and so it's going to wear down quicker. So 20 degrees is a durable knife. 17 is the sharpest knife. So I decided I was going to do a 19-degree angle, kind of a compromise, so I could impress my friends, and they wouldn't know that their knife was not going to last as long as it would if I had done a 20-degree sharpen. So the way this works is very simple. You just take your knife and then put this thing on the knife like so. Then if you're going to sharpen the knife, all you have to do is hold it on the block, and then hold it at the right angle so you can see that the bubble is right in the middle. Then when you turn it on, just keep it there, and if you keep it right in the middle, which is a lot easier than when you have to move the block back and forth, then you will always have the, in this case, 19 degree. To do the other side, you just flip it over like so, and then you're ready for the other side. So that's one important lesson I learned. This little 5-minute, 5-cent device, which is actually more important than this lot more than 5-minute project that I built that cost a lot more than 5 cents. And I would say that this is definitely worth making if you decide to get a knife sharpener, because it makes a big difference. Well, the other thing that happened, which is, the irony. I was running this thing, and by this point, I had done 2,600 different, strokes. So I put this thing through its paces, and it started to make a squeak noise. I mean, there is a noise that you can hear when this thing is on, when the knife is sharpening. But there's also a noise that I can hear now that I didn't hear before. So that would mean I have to take this whole thing apart. And this black thing is a really cool race here that I got out of something. That was the inspiration for this whole thing, this really no degrees of freedom, just very straight back and forth, highly engineered piece of junk. I don't know what it's even from. So that's what caused me to build this whole thing. Well, I realized I'd have to grease it up, and I thought, well, that's going to take a lot of time, and yeah. So I thought, well, maybe I should just try sharpening knives by hand. So here we have the knife sharpener, which is my final build. It's no build at all. It's just, here is the coarse, here's the medium, and what I ended up doing is just trying it like this and getting it right at the 20-degree angle here, and then this is great because you can press really hard. You don't have to worry about stalling out the machine over there. And you can just go a lot faster if you want to and just go across. So, that's how I ended up finishing my project. Not having a project at all. But the knives are really sharp. Bye-bye.